folks. I hope you're doing well today. I'd like to spend some time discussing quadratic applications, also known as word problems. But a few of the homework problems are not really word problems at all. For instance, this number 1, find the domain and range for f of x equals 3 parentheses x plus 1 squared minus 2. Now, you'll remember, if you're current on your homework, you'll remember that this is a quadratic function. How do I know it's quadratic? Because of the square. And for a quadratic function, you have a vertex, right? Now, in this form, I can read directly that the vertex is -1, -2. Remember where I'm getting that from? This is what we call standard form for a quadratic function. It can be written as f of x is equal to a times x minus h squared plus k. And hk is the vertex. Now, really, what we're doing is we're taking the opposite sign of what's in the parentheses. You notice there's a negative in my formula over here, which means h is the opposite of this +1. It's -1. But the k is plus k outside, so you keep the same sign. So there's my vertex, -1, -2. And just for something for you to think about, remember the a? If the a is positive, like in this case, 3, that means my parabola opens upward. So if I were to graph it, and this did not ask us to graph it, but I just want to show you this. If I were to graph it, I would go to -1, -2, there's my vertex, and I know that my parabola opens upward. Now that's just a rough sketch of my graph. I'm not trying to make it pretty, but that's what it looks like. But now, if I know that, then I can easily say my domain is all real numbers. Okay, so I could write that as -∞ to infinity. I could also say all real numbers. It just depends on how you're asked. And the range, on the other hand, remember range is low to high. So the lowest value, because this parabola opens upward, the lowest value on this graph is -2. The -2 is included. The highest value on this graph is infinity. Or another way to say that is f of x is greater than or equal to -2. Again, both of these answers for range are correct. They're both correct. It just depends on how you're asked. Okay, so hopefully that helps. So to find the domain and range of a quadratic function, you really need to know the vertex. If the parabola opens upward, the range is going to be from the y value, you notice that, right? The y value of the vertex up, which is what we have right here, okay, or here. If the parabola opened downward, the range would be from -∞ to the y value of the vertex. So let's try another problem. Find the domain and the range of g of x equals -4, parentheses, x minus 5 squared plus 1. Once again, I have given you a quadratic function, we know because of the squared, and it's already in standard form. So I can read the vertex right from the function. So it's always the opposite of the value being added or subtracted from the x. Okay, in this case we're subtracting, so the x value is 5 of the vertex and the y value is 1. We keep the same sign on the outside. Now this parabola opens downward. So if I were to do a super quick sketch of this thing, I would go over to 5, 1, and open it downward. From there, you can quickly tell that the domain is -∞ to infinity, or you could say all real numbers. Okay, and the domain of every parabola is that. There's no trick. The domain of every parabola is -∞ to infinity. It's the range that changes due to the vertex. And since this parabola opens downward, we're talking -∞ all the way up to 1, and it doesn't go any higher than 1. Okay, and that's your maximum at 5, 1, or y equals 1. Another way to say that would be f of x is less than or equal to 1, right? Because f of x is the y value, and it is either smaller or up to 1, and it doesn't go any higher than 1. Now for a third attempt at this, we're trying to find the domain and the range, same two questions. But this time, our parabola is not in standard form. But we still need to know the vertex. So remember, to find the vertex of a parabola not in standard form, we use the formula that x is equal to negative b over 2a, and then the y value is just f of the vertex, okay, or the x value. I'll say the x value of the vertex. All right, so negative b over 2a. So x is equal to, now what's a, b, and c, right? A is negative 3, b is negative 12, and c is negative 11. So if I calculate negative b over 2a, that would be negative of a negative 12 over 2 times negative 3. You see that? Again, a is negative 3, b is negative 12, c is negative 11. All right, so negative b over 2a simplifies into positive 12 in the numerator divided by negative 6 in the denominator. In other words, negative 2. So far I know my vertex is negative 2. Now I've got to find the y value. How do I do that? I just substitute negative 2 into my function. So g of negative 2 is going to be negative 3 times negative 2 squared minus 12 times negative 2 minus 11. That's all I have to do. So negative 2 squared, you know, order of operations, the first thing I'm going to handle is negative 2 squared. And that gives me 4, so negative 3 times 4. This negative 12 times this negative 2 is plus 24 minus 11. Negative 3 times 4 is negative 12 plus 24 minus 11. Now we know negative 12 plus 24 is 12. 12 subtract 1 is 1. So the y value of my vertex is 1. So here's my vertex, which means my domain, and by the way, I didn't need my vertex to find domain. Domain of every parabola is negative infinity to infinity. It's the range that changes depending on the value of the vertex. Now, before I just say what my range is, I need to know whether this parabola opens upward or downward. But right here, the key is right here. When you have a negative a, we know that this opens downward, which means that 1 is a high point. So our range is going to be from negative infinity to 1, and then it stops. And if you needed to graph that to see, you would go to negative 2, 1. Here, it opens downward, and then you see it right there. Negative 2 to 1, and the graph stops. You could also say f of x is less than or equal to 1. That works as well. So just to drive the point home, I have one more of these. Probably worth pausing the video and make sure you know how to do this. So to find the domain and range, I need to know what this graph looks like. To know what this graph looks like, I'm just going to graph it, or at least find the vertex. So again, the vertex, to remind you, the x value is negative b over 2a. The y value is just the x value plugged into the function. Okay, so x is equal to negative b. Now what's b? Remember, a is 4, my bad. B is negative 16, and c is 10. So negative of a negative 16 over 2 times 4, which is going to give me 16 over 8, which is 2. So my x value is 2. How do I find my y value? I take that 2 and I just plug it into the function. So g of 2 is 4 times 2 squared minus 16 times 2 plus 10. So 2 squared is 4 times 4 is 16. Minus 16 times 2 is 32, plus 10, 16 minus 32 is negative 16, plus 10 is negative 6. So my vertex is 2, negative 6. Does this parabola open upward or downward? Well, look, it's a positive 4, so this thing opens upward. What does that mean? Well, if I go to 2, negative 6, right here, it looks similar to that. Now, they didn't ask us to graph it, but it only takes a couple of seconds to do a rough sketch. That makes it clear to see that the domain is negative infinity to infinity, and the range, remember low to high, well the lowest value on this graph is down here at negative 6, and the highest value is infinity. Another way to say that is f of x is greater than or equal to negative 6. Alright, now for the fun problems, the actual word problems. So we're supposed to find the dimensions of the rectangular corral producing the greatest enclosed area given 200 feet of fencing. Okay, so what do? Well, drawing a picture is the best way to start. Okay, so we have our picture, a rectangular corral, just show a rectangle. Now it says that we have 200 feet of fencing. So think about this, my fence has to go all the way around this rectangular corral. Okay, now I need some variables here. When we're talking about a rectangular corral, what measurements are we talking about? Well, we're talking about, say, a length and a width. And how about we call width W and length L? That works fine, doesn't it? So our rectangular fence will require 2 L lengths, because you got to do the top and the bottom, and 2 W lengths. All right, so that we know we have 200 feet to do 2 L's plus 2 W's. Everybody sees that, right? Again, 2 lengths and 2 widths, and it really doesn't matter which one you call the length and the width. You could have called the vertical lines the length. It really doesn't matter. All right, now we need the greatest enclosed area. So say we have a horse that wants to live in this corral. We want him to have the maximum amount of area. So area, I'm going to write that down, area needs to be maximum. Well, the next thing we need to do is we need to think about how do we calculate area. Okay, so area we know is length times width. So we've got 2 formulas, and for many of these application problems, you're going to have 2 formulas. And this one of them is going to be the one you're trying to maximize or minimize, and the other one is called a constraint equation. Okay, and that's your restrictions on your information. So your goal every time is to solve for the constraint equation. Now you can solve for any variable L or W to plug into L or W down here. Okay, so here I go. I'm going to rewrite. I have 200 equals 2L plus 2W. Now it's entirely up to you. Do you want to solve for L or W? I think I'm just going to solve for L. So I'm trying to get this L on one side of the equation by itself. So I'm going to subtract 2W from both sides of this equation. Of course, the 2 W's cancel on the right. On the left, I have 200 minus 2W equals 2L. I still haven't isolated the L, so now I'm going to divide by 2. These 2's cancel. All right, now 200 minus 2W over 2. Do you notice that each one of those divide by 2? 200 divides by 2 to give me 100, and 2W divides by 2 to give me minus W. So this is L. Now that's certainly not my answer, but I'm going to put it in a rectangle because I want you to see what you do next with it. My next step is to substitute that into my maximum or minimum equation. So now I have A. We know it's length times width, but I'm going to remove the L and replace it with 100 minus W, and then I'm still times W. All right? Now, I need to maximize this equation. In other words, find the maximum. How do we do that? Well, we need to know if it's quadratic. Is it quadratic? That's the first question. Because if it's not quadratic, we might not even have a maximum or a minimum. But we know it is. Why? Because simplify it. If I distribute that W inside, I have 100W minus W squared, also known as negative W squared plus 100W. You agree? That is a quadratic equation. Now I have to find the vertex of this quadratic equation. Now what I'm going to do, I'm just going to erase part of our page right here. I'm going to erase my picture so I have space so I can find this vertex. So I'm back, completely erased. Now negative W squared plus 100W. What's A? What's B? What's C? So remember, A is negative 1. B is 100. What the world's C? C is 0 because there's no C, right? So if I calculate negative B over 2A, remember that's the X value of the vertex, that's going to give me negative B, so negative 100 over 2, and a is negative 1. That's going to give me 100 over 2, which is 50. Okay? Now remember, we're not talking about x in this case. We're actually talking about w. So we know that w equals 50. What does that mean? Remember what w was? If I go back and draw my rectangle back up here for you, remember that's w and that's L. So that means the width is 50. How do I find the length? Well, we've got a formula right here. 200 equals 2L plus 2W. Even, we've solved down here for L. So L is equal to 100 minus 50. So L is equal to 50. So it's going to ask you, what are the dimensions? And you would say the width is 50 and the length is 50. Now what did that really mean about our problem? Well, that meant that a square maximizes the area. And that makes sense, right? You would have the biggest area in your corral if you made it a square. All right, problem number 6. What can we do with this? It says find the dimensions of the rectangular corral, here we go again, split into 2 pens of the same size, producing the greatest possible enclosed area given 300 feet of fencing. Okay, so I think at the top of the page here I'm going to draw my picture so I have a little more room to do calculations. So we have a rectangular corral. Here's my rectangle. Now it says it's split into 2 pens, the same size. So that means if I split that into 2, I would have a line right down here. Okay, 2 pens the same size. There we go. Now, I still have to calculate the amount of my fence. Now if you want to, we can call this distance across the bottom, let's call that x. And then the height right here, or the width, we could call that y. And you could call it L and W too. It doesn't matter to me. For some reason, this problem leans more towards X's and Y's. Okay? So that length across the top, that would also be X, wouldn't it? All the way across the top. Now, our fence, we have 300 feet of fencing. So how do I build my fence? Well, first of all, we know we have 2 lengths of X going on. So that's 2X. But you also have 3 lengths of Y. So plus 3Y. Does everybody see that? So there's 2 X's, and then there's 3 Y's, and that's the entire fence, because you need that piece down the middle also. So that's what we call our constraint equation. On the other hand, we're trying to maximize area. So remember the formula for area is length times width of any rectangle. But our rectangle, the length we called it X, and the width we called it Y. So we're not going to worry about that Y fence in the middle as far as area goes. We're just going to say the full length X times Y. So area is X times Y. So our first 3 steps are to draw, to write down our constraint equation, and then this guy right here is the one we are trying to maximize. And to maximize, we need the vertex. But we have to have just one variable in my equation, so that's why we solve this constraint equation. So now I'm going to solve for X or Y. It really doesn't matter. I'm just going to solve for X because it's written first, okay? And then we'd have all Y's in our equation, which is fine. So to do that, I'm going to subtract 3y to the other side. So I have 300 minus 3y equals 2x. Remember, I'm solving for x. It's perfectly okay if you solve for y. The next step is I'm going to divide everything by 2. So the x is completely isolated. So I have x equals on the right. Now 300 divided by 2 is 150. And 3y divided by 2, well, that's not nice. I'm just going to write 3 over 2y. Now I'm going to circle this so I can find it later in the problem. And I'm going to take that value and substitute it in for the x right there. So now I know my area is equal to, in parentheses, 150 minus 3 halves y times y. Now I have a function of my y value. So the area of this rectangular corral is a function of these y values. Is it quadratic? It sure is, because when I distribute this y inside, I now have area is equal to 150y minus 3/2 y squared. You might like it better with the square first, so that'd be negative 3/2 y squared plus 150y. Now I have to find the vertex, because this is a parabola. Remember, the vertex is equal to, I'd say y equals, because a y is what my function value is, negative b over 2a. So it'd be negative 150, right, over 2. My a is negative 3/2. I simplify this complex fraction. The two negatives cancel. The 2 times the 3/2 also cancels. So it's really 150 divided by 3, which is 50. So I know that my y value is equal to 50. How do I find my x value? Well, as long as I didn't make a mistake over here, I know that x is 150 minus 3/2 y. So 150 minus 3 over 2 times y is 50. Okay, so I have 150 minus 75, right? This 2 goes into this 50. 25 times 3 is 75. And we know 150 minus 75 is 75. That's my x value. So my dimensions are x is 75 and y is 50. All right, you ready to try it again? I'd imagine you've probably had enough of this Corral story, but just to drive it home to make sure you're comfortable with these, it says find the dimensions of a rectangular corral. Okay, so let me draw my rectangular corral at the top of the page. There we go, rectangle. That produce in the greatest enclosed area split into 3 pins of the same size. So I'm going to divide this into 3 pins, which means I need 2 lines on the inside, right? You see the 3 spaces. And we have 500 feet of fencing. I think at the top of the page, I'm going to go ahead and write my 2 equations. Now let's label some stuff here. Let's call this whole length across the bottom, let's call that x. And then these vertical, call it y. So there's y, there's y, there's y, and of course at the top of the page is also x. So that we know our fencing, which is 500 feet, I'm going to have 500 is equal, well, there's 2 x's that are going to have fence on it, and then there's 4 y's that will have fencing. You agree? So 2 long lengths and then 4 of the y values. Now, my area, I'm trying to, once again, maximize my area. So area is length times width for any rectangle. Well, the length of my rectangle we're just calling x, and the width of my rectangle I'm just calling y. You only need 1 y. You're talking about, you know, all this area. Yeah, right, we're talking about all this area. So just length times width. That's it. All right, now again, notice I have 2 equations. I have a constraint equation, which is the top one, the 500 equals 2x plus 4y, and my area equation is the one that I'm trying to maximize. But I can't maximize it unless it has 1 variable. This is a function of 2 variables, an x and a y. So what I need to do is solve for x or y in the top equation and then substitute in the second equation. So I'm solving for, let's just solve for x again. Okay, so I have 500. If I'm trying to get the x by itself, I need to subtract the 4y equals 2x. You agree? So I just move the 4 over to the left-hand side. Now I'm dividing everything by 2. And you can separately divide those 2 terms by 2. 500 divided by 2 we know is 250. Minus 4 divided by 2 is 2y equals x. I'm going to square this off so I can find it later. And I'm going to substitute that x value right there in my maximize equation. Okay? Same steps every time. So I have area is equal to x, which is 250 minus 2y times y. Now, is that quadratic? Well, if we distribute the y inside, I have area is equal to 250y minus 2y squared. Sure, that's definitely quadratic. If I rewrite it in descending orders, that'd be negative 2y squared plus 250. We know that this is a parabola that opens downward because the leading coefficient is negative. Okay, the A is negative. All right, how do we find the vertex? Well, remember the vertex is formula x equals negative b over 2a. In our case, this is y equals negative b. What's b? 250. So negative 250 over 2 times a is negative 2, which simplifies the two negatives cancel. That's 250 divided by 4. And 250 divided by 4, if you're allowed to write decimals, 62.5. If you're not allowed to write decimals, you just reduce these both by 2. So you could say 125 over 2. They are the same thing. It just depends on how you're allowed to enter your answers. Now, how am I going to find the extra stuff on the screen we don't need? How am I going to find y? I'm sorry, how am I going to find x? I know what y is. It's right here. Remember, this is my y, 62.5. X over here, so I squared it off. X is equal to 250 minus 2 times 62.5. That's 250 minus 125. 250 subtract 125 is 125. So basically, we could say our length is the x value right here at 125. And our width is the y value, which is either 125 over 2 if they want it as a fraction, or 62.5 if they'll accept a decimal. So after the third time you see that problem done, you're like, I got it. You do, right? You've got this. And since you do, let's change the problem. So among all of the pairs of numbers whose sum is 6, find the pair with the largest product. Now, it turns out this is exactly like the problems we were doing before, but I know it doesn't read the same way, does it? So among all the pairs of numbers whose sum is 6. So what does that really mean? It means you add two numbers and it equals 6. What are the numbers? Well, I don't know. That's what we're looking for, right? So I say x plus y. How about I say my pen? There we go. X plus y equals 6. So that's the sum of two numbers is 6. It says find the pair with the largest product. What is product? Multiply. What are we multiplying? The same two numbers. So I would say x times y equals, and we're trying to find the largest value, so I'm just going to call it max for maximum, just like area earlier we wanted to maximize it. Now the process is the same, y'all. So my constraint equation is that top one. I've got to solve for x or y, and then I just plug it in to the next one. So I'm going to solve the top one for x. Why not? So I'm going to subtract the y over. So I know x is equal to 6 minus y. In other words, again, I just got the x by itself by subtracting y on both sides. I'm going to rectangle this thing off so I can find it later. I'm also going to substitute that in for that x right there. So now I have my max equation is equal to parentheses 6 minus y, which is my new x value, times y. Is that quadratic? Sure is, right? I distribute the y, that's 6y minus y squared. We like it better with the y squared first, so I'm going to say minus y squared plus 6y. And you keep calling it your max equation. Now I'm supposed to find the vertex. How do you find the vertex? Remember, negative b over 2a. So my b is 6. My c is 0 out here. There is no constant. So my b value is 6. So it's negative 6 over 2. My a is negative 1. So that's going to give me negative 6 divided by negative 2 is 3. So I know my vertex is 3 for my x value. Okay, or I could say that's my y value, right? Remember, the y is the variable in the equation. So y equals 3. How do I find x? Well, I can use my equation right there. X is equal to 6 minus 3. So x is also 3. So what are the two numbers? 3 and 3. Now look, y'all, just think about this. Two numbers that add to 6, like 1 and 5. When you multiply them together, you just get 5. Or 2 and 4. When you multiply them together, you get 8. But when you do 3 and 3 and you multiply them together, you get 9. And 9 is the biggest product you could possibly have when you multiply two numbers together that add to be 6. That's all we found. But the process is identical to the Corral problem, don't you think? It is, even if you don't think. Let's try another problem. Now, you may want to pause it and try this one on your own and just see if we match up, because this is so similar to the last problem. But we know usually you need two equations. I don't want to tell you 100% of the time because sometimes they just give you an equation that's already the maximum or minimum function. But these wordy word problems that don't have a function just given to you, you're going to need two equations. Among all the pairs of numbers whose difference is 12, what does that mean? That means x minus y equals 12. That's my constraint equation. It says find the pair with the smallest product. So when we subtract these numbers, it gives me 12, but they want the pair with the smallest product. So that's a minimize problem. Still a vertex problem. Whether you maximize or minimize, it's a vertex problem. And product means multiply. So I'm multiplying x times y, and that's supposed to give me a minimum. Okay, or you could call it f of x if you want to. Remember, the goal every time is to solve for x or y and then substitute in the next one. So I'm going to solve for x. I think that's what I've done every single time. So I want to get this x by itself by adding y to both sides. What does that give me? Well, that gives me that x is equal to 12 plus y, or y plus 12, whichever you like better. I'm going to square that off so I can find it later, and I'm going to substitute that into that x right there. So my minimum function, or my minimum equation, is x, which is 12 plus y, times y. Is that quadratic? You bet it is, because when I multiply that y inside, I have 12y plus y squared. I could rewrite that with y squared plus 12y, because we all kind of like descending power order, right? Notice in this case, I've got to find the vertex to minimize or maximize. It doesn't matter which one they ask. I have to find the vertex. Now, the vertex in this case we know is a minimum because this thing opens upward, right? Because the leading coefficient's 1. The other problem we did, it was a maximum because it had a negative leading coefficient and it opened downward. All right, so here we go. Remember, it's negative b over 2a. And that's y equals that because there's a y as my function variable. So negative b, negative 12, over 2 times 1, which is going to give me negative 6. So I know my y value is equal to negative 6. How do I find my x value? Go back. Remember, x is equal to 12 plus y. And y is negative 6, so that's 12 plus negative 6. So x is equal to 6. So there's my two numbers, 6 and negative 6. When I multiply those together, I get negative 36. And there's no way you could get a smaller number than negative 36 if the difference is 12. All right, how about a different type of problem? Suppose that the price per unit in dollars of a cell phone production is modeled by, and then they give us a function. P equals 45 minus 0.0125x, where x is in thousands of phones produced. And the revenue represented by thousands of dollars is revenue equals x times P. Remember what P is. Okay, so back up here, because this reads confusing, but it's not bad. There's my P, and then revenue is x times P. It says find the production level that will maximize revenue. So we're supposed to maximize. And remember, all that really means is if you have a quadratic equation, you find the maximum or the minimum. In this case, we'd find the maximum. Okay, we could do this. First of all, it's asking about revenue. So how do we find revenue? Well, revenue is x times P. And P is 45 minus 0.0125x. Is that quadratic? You bet it is, because when I distribute that x inside, I have 45x minus 0.0125x squared, right? If we write it in descending order, which makes me feel better anyway, 0.0125x squared plus 45x. And this is the guy we're supposed to maximize. How do you maximize a quadratic? This is for quadratics only. You find the vertex. So remember, the vertex is negative b over 2a. So that's negative 45 over 2 times negative 0.0125. And then I'm going to reach for my calculator. I know it's going to be positive. And what I'm doing is doing 45 divided by the two negatives cancel. And that's going to be 2 times 0.0125. And I've got 1,800. So that's the production level. Remember, what did we find? We found x. Okay, X is 1,800. And it says X is right here, thousands of phones produced. So if we produced 1,800 phones, then we will maximize our production level. It didn't ask for the price. I had to go back and read what P stood for. I thought it was price, but I want to be sure. It didn't ask for the price, it just asked for the production level. You got to be careful when you do these problems and read the question. For instance, if I go back, bear with me while I go back one problem. It says, find the pair with the smallest product. We found the pair, X was 6 and Y is -6, but it also said, what is the product? Right here. Notice I didn't find that. I did say it out loud, but I didn't write it down. So if they asked for the product, it would be, you multiply those together, as what product is, it would be -36. So just be careful with what question is asked. Make sure you read that a couple of times. So now we have another problem. A rocket is launched in the air. Its height in meters above sea level as a function of time in seconds is given by h of t, and they give us a function. It is a quadratic function. You notice that because it's got the square in it right here. Okay, find the maximum height. So we're basically just supposed to maximize this guy right here. Now it looks complicated, but this is maybe the easiest problem we have. So I'm supposed to maximize something that's already quadratic right here. Then we just find -b over 2a. So that's going to be negative. My b value is 229 over 2, and my a is -4.9. Now be careful what variable we're talking about here. Well, there's a t. What did t represent? Time. So when you calculate -229 divided by 2 times -4.9, you're getting a time. Okay, so I'm going to type that in my calculator. Now the two negatives are going to cancel, so I'm not going to worry about that. 229 divided by, and make sure you type in parentheses for your entire denominator. Okay, so that's 2 times 4.9, and I've got something that needs rounded, so you got to be careful about that. I'm going to round maybe 3 decimal places, but definitely read your problem. I should have put a place to round in this problem, and I didn't in the directions. That's my fault. It should have a place to round, so I just decided in the middle of the problem. So the time is 23.367 seconds. Now look at the problem. It says find the maximum height. Well, how do I do that? Well, this is a function of height, so I need to find h of 23.367. Now, if I would have rounded something a little smaller there, this would be an easier calculation. But I'm going to stick to what I said. Okay, squared plus 229 times 23.367 plus 234. Give me just a minute, and I'll tell you what I get. So I've got -4.9 that I'm multiplying times 23.367 squared. And then I'm adding that to 229 times 23.367. And then I'm going to add 234 at the very end. And I get 2,909.561. I seriously doubt you have to go that far out. Remember, this says its height in meters. So this would be meters. And there you go. So I have 3 more examples for you. If you'll recognize this, this looks just like the last problem. I had to make sure it wasn't the same. No, it's not the same, but notice it is just like the last problem. So we have a ball. It's thrown from the top of a building. Its height in meters above the ground as a function of time in seconds is given as follows. How long does it take to reach a maximum height? So once again, you have a quadratic function. Okay, this height function is quadratic. It is in meters, where t is in seconds. So paying attention to all your units really is important. Sometimes I glaze over that, but it really is very important. All right, so we have a quadratic, which means we need to find the vertex. Now the question is, does this quadratic open upward or downward? Well, we know it opens downward, right? Which means it's going to have a maximum or a max height, and that's the vertex that we're finding right now. So that is going to be t is equal to -b over 2a. So that's going to be negative. My b is 24 over 2. My a is negative 4.9. I typed that in my calculator. Give me just a minute. You can do it with me. And I get something that's not nice again. Let's go out 3 places. So 2.449. Remember, that is in seconds. So it takes just under 2.5 seconds to reach its maximum height. But what is the maximum height? No, it says, listen, actually it doesn't say what is the maximum height. It just says how long does it take to reach the maximum height. So we're done. If it asked for the maximum height, we'd have to plug it back in. This says how long. So we're done. That's it. That's all we have to do. Yay! Okay.